I think we are now live. I'm hoping that everyone can hear us loud and clear. We'll start in just a couple of minutes. Let's have a look. We've got 22 people.
That's pretty good.
In attendance. I think we're expecting about 40, so we'll just give it until a couple of minutes past until we get started. But thanks everyone for attending this this webinar about lighting. Hopefully we'll be able to impart some knowledge and perhaps gain some knowledge from you guys as well. So if anyone's wondering, we are in the UK. We're based in Norfolk, in East Anglia, near Cambridge. I think everyone's heard of Cambridge University. So that's where we're based at the moment. And fortunately, the sun is shining.
For now.
For now. Oh, thanks, Matthew. You're welcome.
Mm.
Good. We're coming through loud and clear.
Oh, that's good.
So I think we've got people in Malta. I recognise some names. We've got people all over Europe, Belgium, Italy, and as far flung as China and Taiwan. So we are global. Okay, so I think we'll get started. Also, thanks everyone for tuning in. This is a sort of informal discussion really about lighting for infrared reflectography. We're going to be sort of a bit of a to and fro from me and Andrew. I expect we'll probably last about half an hour, but we may run over depending on how many questions you guys submit. So the question bit will come at the end, but let's just introduce ourselves. So my name's Catherine Wilkinson, and I am the Business Development Executive for Opus Instruments. So if you've been emailing in for quotes or to find out information about the cameras, then you would have probably been speaking to me. And then Andrew, who's that way, is our technical support manager, who has a very impressive background in physics and scientific research. And he was heavily involved in the production of the Osiris camera and continues to do so with the Apollo. So thank you very much, Andrew, for tuning in. Okay, so the agenda for today is very, very straightforward. We are going to discuss the two main lighting techniques that we're familiar with, and there may well be many other little nuances or little hacks or tricks that some of you seasoned Apollo and Osiris owners are familiar with or use, and we'd be interested to hear if you have any comments or feedback on any of the slides, because you guys are the experts in some respects. So we'll cover infrared reflectography, we'll cover transmitted infrared, also known as IRT, and then we'll show you a series of slides demonstrating some sort of common mistakes with lighting, how to spot them, how to sort of recognise what they are, what they look like, and then how to avoid them. And then we've already got some questions, but we welcome your questions through the chat function. and we'll try to answer them all. So without further ado, let's start with the basics. You may well be familiar with this diagram. It's all schematic. It is showing infrared reflectography. So in this schematic, you've got the camera facing the painting or object, and you have two halogen light sources either side of the camera. You'll notice that the lights are behind the camera. This reduces or prevents light, unwanted light from bouncing straight back into the sensor. If you were to have the lights in front of the camera, then you will start to see some rather dodgy images. We recommend starting off with a position of about 30 to 60 degrees. And that's going to give you good even coverage of your painting or object. And then you can go wider. I mean, that's quite narrow. That schematic shows quite sort of narrow. The lights are very narrow there, but you can take them a lot wider, and we'll go into that in a little bit more detail. So this is the sort of standard infrared reflectography, and again, we can send you these slides. So don't worry, we'll send you copies if you need. And then there is another method of illuminating your canvas or object, and this is called transmitted infrared. So you will see that the camera is one side of the painting, and the illumination source, the halogen light source, is behind it. And this method is perhaps a little less well known. But this method is particularly effective when your painting is highly reflective. So if your painting has lots and lots of layers of varnish on it, and illuminating it from the front using the standard infrared reflectography technique, reflecting light back off the front of the canvas, then you could get a bit of glare, and the image quality won't be sort of a publishable standard. So with this method, with transmitted infrared, what you're doing is you're essentially shining a light through the canvas from the back, and then the light transmits through it into the camera. This method is also particularly useful if you have a painting that has really thick impasto with lots and lots of layers of paint. So, you know, if you're illuminating a very thick impasto from the front, it can be quite hard for the light to penetrate those layers of paint and then show you the infrared back. So yeah, this is a bit lesser known, but certainly a very effective technique adopted by some quite esteemed people in the field. Okay, so we've got those two main techniques. So there's another way that you can do your lighting, and this is to sort of combine both techniques. So essentially it's the two techniques. You've got the lighting from the back, the transmitted, and then you're bouncing the light, reflecting it on the front of the canvas or object. And this is, again, it's particularly helpful if you have got you know, the thick impasto, you have lots and lots of layers of varnish, but when you do your standard IRT, the front of it, you're just not getting the right amount of illumination. So if you bounce some light off it, if you reflect some light off the front of the canvas, then you're going to be you're going to get bang for your buck, and we'll demonstrate that in some images later. Anything to add to that, Andrew?
Could we go back to the first slide?
Yeah.
So this one, I think it's worth saying, the principal reason for wanting to position your lights in line with the camera or slightly behind is to preserve the black levels in the image. If you have the light slightly in front of the lens, then as well as the information coming off the painting, then you could have light coming directly from the light source into the lens and then into the camera itself. So what that would mean is you would never ever see a true black in the painting, because you'd only cover a level of kind of dark grey to perhaps bright white. So that's a way of preserving your contrast. And the other interesting thing about this traditional setup is if you don't have the facility to dim down some very bright lights, you can be in this awkward situation where you have to put the lights at quite a long distance from the object. And that results in quite an amusing situation, because what happens in that case is that you can be casting a shadow onto the painting because the light's behind you as well. So that means if you're going to take an image of about 15, 20 minutes, you've either got to remain perfectly still throughout that time, or you've literally got to press go and then leave the area. So yeah, I think that's all I have to say on that particular setup. Thank you.
And then the transmitted infrared, is there anything you think I've missed on that one?
Just to reinforce the fact that if you don't have a barn door or cat flap type situation around the edge of the painting, then you could end up, depending on your light source, you could have some lighting go direct into the front of the lens, which you don't want. You want to block out any direct incident light. It's quite easy to do with just cutting up some card and putting it around the painting.
Yeah. Okay. And then we have the combination. This was quite fun putting this this bit of graphic together. I hope it makes sense to you guys, and we can certainly explain this in a bit more detail if anyone has any questions about this. But yeah, these are the main lighting techniques, and it's. I mean, I think one of Andrew's first pieces of advice for me when I started at Opus Instruments was just experiment with the lighting, and I think that's key, is to just experiment, because there may just be a little nuance that you find, just a small change or a tweak that gets you an even better result. And please do let us know, because we're always interested to find out what works for you guys. Okay, so here we have some imagery. So this on the left hand side you have a rather washed out picture, so excuse that was taken on my camera phone this afternoon, but you get the idea. This was a standard photo in visible light, and it's oil on canvas. And so we're really just comparing and contrasting. Now, one thing to bear in mind with this particular painting is the canvas is it's relatively thin, and the paint layers are certainly it's got relatively thin paint layers, so we're not looking at really thick impasto here. So with that in mind, the second image, the middle image that you can see, is with transmitted light. So this is the camera at the front of the canvas and the light source coming from behind, illuminating it through the canvas. And so on the bottom left-hand side, you will see those black bits obscuring the two figures, and they are canvas supports made out of wood. Hence, you can't see much there. But if we want to compare and contrast, the far right-hand side is the combination of illuminating it from the front and from the back. So you've got two light sources either side of your camera in that standard infrared reflectography lighting technique, and then we're illuminating it from the back. So you're just getting a little bit more brightness there. And yeah, it'd be interesting to see if any of you guys have experimented with that particular technique of combining the two. I believe on our website we have a case study kindly provided by Studio Redivivus in the Netherlands, and it's a Lucian Freud case study. And I'm 99.9% sure that was that the images on there, the infrared images, were taken using this combination of techniques. Okay. Happy with that, Andrew?
Yeah, I guess it's worth saying that for the transmitted situation, that's not going to work on every situation, because if you've got a reused canvas, which maybe has got a stack of 2 or 3 paintings on it, you've got lots and lots of opaque paint on there, then you're probably not going to get a great benefit from using the transmitted situation, which is why the reflectography situation is a kind of default. But I think it's worth experimenting with, and you've got nothing to lose really. So it's just another tool that you can play with.
Brilliant, thank you. Okay, let's move on to the next slide. So yeah, transmitted infrared, just a quick summary. Well, not a quick summary, but just thinking of the main issue that you'll probably encounter if you are setting up the light to transmit through the canvas, is that you'll get light escaping around the canvas, especially if it's really small. If you've got a really small canvas and you've got a big old halogen light behind it, then you don't want light escaping around it and getting into the sensor, and that's going to give you some very odd images. So there are a variety of ways to sort of work around that and resolve that issue. So you could bring the light source closer to the canvas, but then unfortunately the heat incident on the canvas will increase. So that's a consideration. You could increase the exposure time in the software and dim the light somewhat, but that still doesn't necessarily get to the bottom of the problem. The next one is if you have lights with barn doors, so sort of blinkers on them, then that's really going to help you no end. And then you could also flip it around the other way and think about bringing the camera towards the canvas. So the sensor will not be taking in quite as much leaking light from around the canvas. And then probably the most straightforward one to do is to put some sort of dark surround around your canvas to block out the escaping light. Now, one thing worth mentioning is that if you have an Apollo camera, is that you have a square imaging area that you can see in the software. And what you can do is you can select the area that you want to. You can select a particular area within the imaging area. So, say you've got a imaging area on the software that's say that size, but your canvas is a quarter of the size of that. Then try and get the canvas in the middle of the imaging area and just crop it down. So then the sensor isn't going quite as wide. Is there anything you'd like to add to that, Andrew? Is there anything you think I've sort of missed?
Well, just to say that my favourite piece of advice really in this sort of area is the one where you're placing a black curtain or surround behind the subject. Because it can greatly reduce instances of troublesome reflections that you weren't even aware of, producing funny things in the image. And also just having a black background gives you a proper baseline so that you have good, strong contrast in the image that you don't then have to, constantly cropping out the background. So I would always go for that one first, if you can.
Yeah, thank you. Okay, let's move on. So just to have a quick recap of the IRR technique, the sort of standard technique, the default lighting technique, lighting from the front. Starting off with your lights at sort of 30 to 60 degrees or wider, if you've got quite a reflective surface that you're imaging, and that will just reduce the amount of sort of glare that you're getting. Another thing worth mentioning is scanning the room that you're in, the environment that you're in, to make sure that any reflective surfaces are covered up. So quite often on an easel, I'm just looking at an easel to my left here, and it has metal screws in it. We've got a wooden frame, but metal screws. And I've covered ours in special parcel tape. And that obscures the shiny surface from the sensor, so you're not going to get any of that off-axis light bouncing back in. So yeah, just keep an eye out for shiny surfaces. There was something you were saying the other day, Andrew, about shiny surfaces, about reflective surfaces. I think it was something to do with when you might not be able to see it in the visible light. Mm-hmm. You might not be able to see a surface in the visible light, but it might be visible to the camera.
Yes.
Can you delve into that a little bit?
Well, sometimes when you set up the lights, you're doing it based on the fact that you can see the visible part. But obviously the camera is not looking at the visible part. It's looking at the IR. So if you get a reflection, a strong reflection, say from some thick varnish or something from the canvas, but you don't see that necessarily from the visible, that's just the reason why that's happening, is that particular layer is very active in the infrared. So I think going up to that top point there, one common thing that everybody will see at some point is they've set the camera up, and then maybe around the edges, or depending on how thick, if it's an old painting that's got a sort of horrible yellow varnish finish, then you might see a real sheen in the actual camera image. So what I would suggest in that case is that you actually open out the angle of the lights much more, so you get a much more of a grazing angle. Then you'll get less direct reflection into the camera.
Yeah, and I mean, just to jump in on that one, I mean, obviously it depends on how large your imaging area is. You know, if you've got a tiny box room, then you do have restriction. You have got restrictions there. But yeah, getting the lights out nice and wide and giving yourself that space, if you can, would be really, really helpful.
And I guess something we haven't really covered here, although it's a sort of a more general thing, where we talk about blocking out natural daylight. It's always good to reduce natural daylight coming in, because obviously sunlight does contain a portion of IR that the camera can detect over its imaging period. And if your typical image is taking 15-20 minutes and the cloud changes in the background, then obviously the amount of sunlight coming into your room will vary slightly. You've got a slight gradient in the image, which is going to be problematic to remove. But you don't have to necessarily block out all of the sunlight, because remember, we have that black filter on the front of the camera.
Yeah.
And that is to try and remove or mitigate that problem. So a nice dark room is good with, just natural fluorescent bulb light. That won't hurt you at all. But you don't necessarily have to remove every bit of sunlight. Yeah. As long as it's not shining directly on the object itself, that would be a problem.
Great. Okay, let's move on. So we've got some examples here. So it does look like it's evenly illuminated, doesn't it? But on this particular presentation, the way that it's uploaded, the image on the left of the sort of the grid lines, it appears to be very poorly illuminated. So I apologise about that. I think it's just the quality of the presentation on this webinar platform. But if you'd like to close your eyes and imagine that that image on the left was evenly illuminated and just one blanket grey level from left to right, with obviously black lines going across horizontally and diagonally and vertically. And that I took that image yesterday, and I promise it was very evenly illuminated. But it was using the infrared reflectography technique, as detailed on the right-hand side there. So let's delve into some lighting issues. So on the left-hand side, you have you can see some pretty terrible lighting, or a pretty terrible IR. So it's exactly the same, but what we've got here is we've got a reflection coming into the sensor off axis. So if you have a little look at the schematic at the top right there, you'll see it's the standard infrared reflectography technique. But at the top right, there is a grey triangle, which is pretending to be a mirror or a reflective surface, bouncing light back into the sensor off axis. So how it presents itself is the large image on the left there, the infrared reflectogram, is the full image. But if you have a look at the middle one, you can see in a bit more detail. If you really sort of squint your eyes, you can see that in every tile, there's a mismatch, isn't there? There's a darker tone and a lighter tone, and this is due to a sort of shield on the sensor, and I'm hoping that Andrew will be able to shed some light on it. Oh, God.
On the Apollo camera, we have quite a small sensor area, and to avoid objects that are off axis becoming problematic and causing unexpected effects, what we have is a cutout mask around the sensor to try and mitigate those sort of things. However, if you've got something off axis which is really bright, then what that can do is actually allow light directly into the lens, but also kind of cast a shadow on the lens. So when you're taking an image using the Apollo and you're looking at the image build up gradually, you might see some unusual marks in each little square of the grid because they're not yet corrected. Most of those should disappear when the camera completes the final image. But if they don't, then look for things that are either side or up or down from the painting to see if there's anything bright. Metal objects that sort of reflect heavily are usually the sort of culprits here. That's why I favour having this background with a black curtain if you can, because you know, that instantly removes those kind of problems. But you can have something over the other side of the room that you're not even aware of that's super bright and reflecting back into the camera. It's just you have to be careful if you have any of these kind of effects.
Yeah. And I'd say, you know, whoever is responsible for your imaging room, you should ask them if you can put a lick of black paint on the wall, non-reflective black paint, matte. Brilliant. Okay, thank you, Andrew. Okay, so moving on to the next slide. Right, what have we got here? So we have the same photograph on the left of that oil on canvas. And on the right-hand side, this is an example of natural daylight coming into the room and entering the sensor. Because the Apollo sort of scans on this horizontal plane, it sort of scans from top to bottom. You imagine it going across the top line, scanning along, and there's no natural daylight coming to the room because there's a cloud outside. And then the cloud goes, and on the second row, the daylight comes in, and it's very, very bright. You're going to get different light levels. And so I created this actually yesterday by dimming and brightening the lights on our halogen lamps, just to sort of give you an idea of what it would look like. So this is, I would say this is a little bit exaggerated, but it gives you an idea of the kind of striation effect that you would see on the horizontal.
So this is exactly why we have this black lens on the front, to try and remove this effect if there is any sunlight coming into the room.
Yeah.
But obviously, it can't work miracles if you've got a lot of light coming in.
Yeah, brilliant. Next slide.
Yep.
Okay. Oh wow, we're on to slide 13 already. That's gone quickly, hasn't it? Okay, so if anybody has any specific questions, please use the chat function. I think that's on now. So there should be a little chat box where you can type in a question. We've already got some submitted via email earlier. So here's some I prepared earlier.
We do actually have, if you click on the moderated thing, you do actually see.
Oh, have we got some?
Moderates, yeah. We have actually got a few questions in there. Can you see those?
Let's have a look. Let me just scroll up. Excuse me. Let's have a look. Okay, have you got that, Andrew?
Yeah.
Brilliant. Okay, so first question from Joey. Hi, Joey. Can you point out? I can't see the question anymore. It's been blanked out. Now. We'll go into public. Let's have a look. Oh, here we go. Thank you very much. Okay, here we go. So question 1 is, can you point out the angle degree in the diagram, which is 30 and which is 60? Okay, yeah, no problem at all.
Just go back up to the first one.
Let me just go to slide number 1. I'm just going to very clumsily scroll all the way back through to number. Let's go through. Where are we? Okay, so what degree would you say that this is at, Andrew?
So basically, when we say 30, we mean closer to the camera, so the angle is becoming more aggressive.
Yeah.
Really, all this 30 and 60 is, a typical setup is going to be 45, and that gives you a plus or minus 15 degree margin on that setup. So don't get hung up too much on the numbers. We're just talking a kind of a rule of thumb here. And as you push the lights further and further out, then that angle is going to get bigger. Yeah, hope that makes sense.
Brilliant, thank you. And again, if if you want some more detailed explanations or answers, then please do send us an email. From Evan, hi Evan. For IRT, is there any difference between the paint layer facing the camera versus facing the light source?
Well, yeah, there will be, because the infrared coming from the conventional setup, where you're looking at reflectography, that only has a finite penetration depth. So that will, depending on the wavelength you're looking at, then that will only penetrate a certain amount before some of it is reflected back. When you illuminate, potentially with a very bright source from the back of the camera, then you're really just talking about attenuation. So you're just looking at which things attenuate the light more severely. So you can imagine if you had a large part of the painting which was say it was brown, mixed from some sort of iron source, then that would attenuate terrifically and you wouldn't get much through. So that would then be combined with whatever reflectography signal you got from the conventional setup in the front. So yeah, there would be a difference in the information that you get combined.
Brilliant. Okay. Thank you, Andrew. I hope that answers your question, Evan.
I think there's another couple of moderated ones in there.
Oh, here we go. Yeah, I did. When I took some of these images yesterday, I did actually flip the canvas round so that the canvas, so the back of the canvas was facing the camera in the IRR mode. So as you can see in that particular slide there, but instead of the paint layers being facing the camera lens, it was just the back of the canvas facing the camera. And I mean, in that instance, it was a little bit harder to differentiate between what was underdrawing and what was actually canvas, but that's to my untrained eye. Again, I'm not an expert. I don't spend days looking at these reflectograms, and so I think perhaps to a slightly more trained eye, you would be able to sort of interpret the results better. But certainly in my little experience I had yesterday by flipping the canvas round, it was a bit more grainy. But again, I mean, I think it really depends on what you're pointing the camera and the lights at.
So we've got another question here from Evan. Any difference between halogen versus tungsten lamps? Okay, so strictly speaking, what you would call an ordinary tungsten lamp is an old-fashioned filament bulb that you'd use 10 years ago to light your house. A halogen bulb is similar, but it has a tungsten filament, but it has a halogen gas in the bulb, which allows it to be pushed harder to create a brighter output for the because they tend to be small lights with an aluminium backed reflector built in. It's the sort of thing that were popular for sort of spotlights, particularly in a kitchen, that kind of thing. So yeah, there is a difference in there, in that the halogen ones are, strictly speaking, the ones that you want to be using because they have the reflector built in, whereas the traditional tungsten lights are just the round conventional bulb, but they will still both output IR. It's just that the halogen ones should give you more for their size.
Brilliant, thank you, Evan. I think that's it for questions in the chat section. So I'm going to skip on to the next slide, and let's have a look here. So I'm interested in the amount of heat that lamps produce. Is there an easy way to measure this? And does the expert know if there's any information on the maximum exposure of heat for a painting, either panel or canvas, or a miniature on parchment or paper? So quite a lot to delve into there. Andrew, over to you. I think this is one that you get asked quite a lot.
Yeah, so I mean, in the conventional setup where you have two lights either side of the camera, probably a couple of meters from the object, then you're not really going to get much heating being conveyed to the painting or object. Where it becomes more of an issue is if you're very close to the painting, where you might be doing that, in the case of when you're using the macro lens. That's one of the reasons why our macro lens comes with the lighting arms that can be positioned very close to the subject, but it also has an inbuilt dimmer built in, so you're never just letting the intensity run out of control. I mean, if you're really worried about that, you can buy these sort of little handheld IR temperature readers with a little laser pointer built in, and they can give you an idea of whether your canvas is getting too hot. I think it's very unlikely for that to happen unless you're really going overkill on the illumination. Yeah,
and I think it's a difficult one, isn't it? But try and have a room that is well ventilated. That can have some small that can sort of reduce the amount of heat, the heat incident to a certain extent. But yeah,
I think in most cases where you have the illumination kit some distance away from the object, that's never going to be an issue, particularly because most of these halogen bulbs actually have a glass front fitted to them to actually reflect a lot of the heat, so it's not being conveyed out the front. So, and
I mean, I suppose another thing that you could consider doing is, if you have a dimmer switch, or if you have you can buy these dimmer switches that your halogen lamps plug into. So obviously we've got one on the illumination kit that we sell, but if you're buying your main halogen lamps, then you can buy these dimmer switch accessories from electrical stores. And then you could perhaps, if you are concerned about the amount, the heat incident, you could turn down the lighting to reduce the heat incident and turn up the exposure time.
Exactly, and I think there's going to be a question about that later. So.
Here we go. Right, so next question is, what gives better results if a scan seems too dark? Increase the lighting of your lamps or increase the settings in the Apollo software? So we've literally just covered that, haven't we?
So, I mean, what I would say to that is I would always use the variable illumination first of all. But you're welcome to experiment with changing the default setting on the exposure from 10 milliseconds to 20, 30, 40, whatever. The only thing that you might encounter, depending on your mains frequency, is sometimes when you increase the exposure time on the software, you might start to get vertical lines as artifacts. So that may limit what you can do in that regard. I always go for the easier option, which is just to fiddle around with the lights. But you're welcome to experiment.
Yeah, let us know what works for you. We learn a hell of a lot from our Opus camera users. So if you find some wacky way of illuminating your objects that haven't been mentioned here, please do let us know, because we're always learning. So question 3 is: are there other light sources with LED or other with which enough infrared light is generated to make IR images? So an alternative to the standard halogen. So this is a burning question, isn't it? I think I'll just jump in there at the beginning, and I think Andrew will probably have a fair amount to say about this, but I think we are getting increasing numbers of inquiries from our camera users saying, I'm finding it quite hard to source halogen bulbs, or and I think it's due to a move towards LED because of climate change and those things. So it's certainly something that we are aware of and we are investigating. We are at the early stages of that, but perhaps Andrew, you can delve a bit deeper into that for us.
Yeah, we are looking into this, and this is going to become excuse the pun, a hot topic over the coming years as conventional IR sources disappear. The problem at the moment is that most LEDs that emit in the infrared are only doing so in a kind of a narrow band, which is fine. You can build a device which has lots and lots of LEDs to do a similar illumination effect as a regular setup. The only problem with that is you're not getting wideband IR, you're just getting a very narrow band of IR. So that means you then can't experiment with filtering out certain parts of a broadband image in order to see whether you get interesting contrast, in one area. So you'd have to have lots and lots of different IR setups illumination setups in order to explore the whole wavelength range. There are tunable IR setups, as there are for use in sort of science applications, but they don't generally have a huge output. They're normally for putting out a very small amount of light for bespoke experiments, and not for general illumination. So we'll have to see how the market develops in that regard. Oh, we've got some more public ones.
We've got some more. I'm just going to quickly skip on to our last.
Okay.
Yeah, this is the final pre-submitted one, and then we'll try and whiz through all the other questions that we haven't got through yet. So question 3 is: how can someone ensure homogenous lighting distribution across a painting, especially when considering large pieces such as 3 by 4 meters? I am asking because until now I've only imaged small paintings and planning to expand to larger ones. So yeah, a light meter could be quite helpful. How would you tackle that, Andrew?
Yeah, well, what I like to do is, your bulbs are obviously emitting in the IR, that's why we're using them, but they're also still emitting in the visible. So I like to use the fact that you've still got some visible light going onto the object, even though the camera can't see it. So what I would do is, if you've got a very large object that you're not confident that you're illuminating evenly, is just get a big piece of white card and put it in the same position. And then you can see by moving the light slightly whether you indeed have a visible, continuous illumination across the surface. That's an easy way to do it. You don't really need to muck around with a light meter. And anyway, that doesn't necessarily help you, because although you could precisely measure the visible light with a light meter, you don't necessarily know that that's still true for the infrared part of the spectrum. So I would advise you to experiment with some white card or something similar, and I find that usually does the trick. That's what we do when we actually calibrate the cameras. One of the tests is actually to take what we call a flat field, and that requires that the illumination is homogeneous before we test the cameras.
Brilliant, thanks, Andrew. Next question is from Michael or Mikhail. Is there an IR pass filter that I could use to decrease unnecessary heat? This one's definitely for you, Andrew. Yeah,
well, basically, unfortunately, not really, because the reason everybody's moving to traditional LED bulbs in domestic illumination in your house is because they remove the IR part of the light, which is normally evident as heat. So you have to equate IR with heat.
Yeah.
If you have any kind of filter in there that is going to remove the heat, then by the very nature you're going to be removing some of the IR.
Yeah, and an interesting, let's just tick this one. Here we go. So yeah, from the same person, from Michael, I have good experience with using a PC ventilator to dissipate the heat on miniature paintings. So that's yeah, that's a good way to do it. I don't know if anyone else in the chat room has any top tips, any feedback for any of these questions at all. Let's have another look. Yeah, from Helene, you can really light up the image in Photoshop afterwards. She always does that. Another question is there a time limit for IRR done on paper artworks, considering the heat of a halogen lamp? I mean, that's a tricky one to have a definite answer for. So I would say the answer is there's no clear answer. I don't know if you would disagree with me or have anything to add.
I mean, obviously something like paper from a book is obviously going to be very fragile.
Yeah.
But again, I would move the light source further away from the object if you can. There isn't going to be a time limit, because that depends on the composition of the paper, how sensitive the drawing or the printed pages, depending on what ink has been used, or so you could have a bleaching problem if it was taking a long time. It is too specific to the subject, unfortunately, to give you a direct answer on that.
Yeah. I mean, this is clearly a hot topic. The pun again. Excuse me. But yeah, the heat incident, and it's clearly something that many people in the field are concerned about. So what we will be doing is we will be sort of compiling a sort of troubleshooting in the field guide as we go through this year with subsequent webinars. But I'll be publishing sort of helpful feedback from you guys, and some of the answers that Andrew and I provided to the questions on the website or in a newsletter. So I'll make sure that everyone gets these answers in some form or another. Yeah, so I think that is it question-wise. So without further ado, I think it's time to wrap up.
Yeah, just to say, it's great to have lots of questions. We had an exceptional number of questions today. You're always welcome to write in using, our web form. Yeah. If you've got any similar questions to this, you don't necessarily have to wait for a webinar. We're always here to answer these sort of things. And, the more we get answered the more we get asked for the same sort of thing, then the more we'll identify that as a frequently asked question and then transfer that onto the website. So your question can help other people too. Yeah,
absolutely. And I would say that, you know, if you've got a question, a sort of practical question about, you know, you're experiencing or you're seeing something unusual in your image, then send in the visible photograph, and then send in the IR, and also maybe take a photograph of your setup as well. So
that's always useful.
Stand back and Andrew or I can take a look and go, oh, you might want to move that or move the camera a little bit that way. And just sometimes there's a tiny little nuance that can give you some really, really good results. So thank you very much for tuning in, everyone. This has been great fun. Please do head over to the website, opusinstruments.com. There's all sorts of information on there. We'll be uploading this webinar, and there are other videos or links to other videos on there. And the website is very, very shiny and new, so we think you'll like it. And yeah, I think that's it for now. So thanks very much, everybody. Have a good afternoon, morning, evening, wherever you are in the world. And hopefully we'll hear from you soon.
Till next time.
Thank you. Bye-bye.